Today we're going to talk about difference of two squares and rhombuses. Now before we get into solving for difference of two squares, what we need to actually do is understand what the word conjugate means, because for difference of two squares you actually multiply by conjugates. Here's what conjugates are. Say you have an expression of 2x minus 3y. Its conjugate would be negative 2x plus 3y. Vice versa, you have negative 2x plus 3y. Its conjugate is negative 2x minus 3y. And one more, 3x plus 4 and 3x minus 4 are conjugates. So therefore, a conjugate, you are simply switching the second sign, or you could say the value, you're doing the opposite value for the second number. That is what a conjugate is. So that's the first phase. Second phase, when two conjugates are multiplied together, the product does not have a middle term. So say we have these conjugates, 3x plus 4 and 3x minus 4. Well, what it's saying is the product does not have a middle term. To find the product of these, we FOIL, right? F-O-I-L. First is 3x times 3x, that's 9x. Outside, 3x times negative 4 is negative 12x. Inside is 4x times 3x plus 12x. Last, 4 times negative 4 minus 16. So, this is a 9x squared. My bad. So here, notice that we have a negative 12x and a positive 12x. They're opposite, so therefore they equal 0 and cancel. So your answer would be 9x squared minus 16. So if we have 9x squared minus 16, now switching this in phase 3, if both numbers 9 and 16 can be square rooted, then multiply by conjugates to find the answer. So 9, square root of 9, it is square rooted to be 3. Square root of 16, that would be 4. So therefore, what we could say to find this answer between 9x squared and negative 16 is we can multiply by conjugates. Now you may, what would be the numbers? Well, the numbers would be the ones that are square rooted. The 3 would have the x attached because it has the 9x squared. So I'd say 3x times, and it doesn't matter which one you put first. It could be negative 4 or positive 4, but 3x minus 4, its conjugate would be 3x plus 4. So notice we just kind of worked backwards there. But that's how you multiply conjugates. So let's look at one example. You get that concept, then the problems are easy. It says solve 4x squared minus 9 equals 0 by factoring. So we have to factor. Well, does square root of 4 have a perfect square? Yes, 2. Does square root of 9 have a perfect square? Yes, it does, 3. So therefore, we would use the 2, and we'd use the 3. The square root of 4, meaning the 2, had the x attached to it. So I would say 2x minus or plus, doesn't matter which one's first, 2x minus 3 times 2x plus 3 equals 0. So we just multiplied by conjugates here. And now, it did want us to solve. Notice it says equals 0, and it wants us to solve. So now from here, all we do is 2x minus 3 equals 0. Did that one? And then we do 2x plus 3 equals 0. And we solve for x. Add 3. We get 2x equals 3 divided by 2. So I would have x equals 3 halves. Subtract by 3. So over here that would be 2x minus 3 equals 0. 2x equals negative 3, sorry. Divide by 2. And what do you notice? These are just opposite, but those would be your two answers. And that is how you solve for conjugates, or difference of two squares is what the concept is. But that's how you solve. Let's move on to one more concept in this lesson of looking at a rhombus. First thing I want to say is properties of a rhombus. You just got to know these three properties. First one is all four sides are congruent. So in this rhombus, I could say boom, 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 boom. All four sides are congruent. The diagonals bisect. So what you just got to know what the word bisect means. Bisect means that it cuts it in two. So I could say this angle right here, this measure is equal to this measure because it's bisected the angle. And the last one you could say is the diagonals are perpendicular. So I'm going to go ahead and put a perpendicular sign there. And I can do it for all of them. I'm just going to do it for those two. The diagonals are perpendicular. Now that we know our properties, that's going to make our problem pretty easy. Example 39.3. DEFG is a rhombus. Find all those. And then it also says 280 degrees is a reflexive angle, or the reflex angle in the rhombus. A reflex angle just goes outside the polygon. And so if this angle is 280, let's look and see what we know. Well, first of all, C is right here. Do we know what C is? Yes, it's a right angle, so therefore 90 degrees. So we got C. Can we find X and A? Let's look at this reflex angle that it gave us. Well, if this is 280, full circle would be 360, right? So, okay, 360 equals 280 plus, now we have angle X and angle K. So 280 degrees plus angle X plus angle A equals the full 360. Now looking back at our properties, it says the diagonals bisect. So if the diagonals bisect, that means X and A are equal. X and A are equal. So therefore, I can substitute, instead of saying 280 plus angle X plus angle K and having two variables, I can say 280 plus angle X plus angle X, because they're the same. Then we simplify. I'm just going to write 2x. 2x plus 280 equals 360 minus 280 on both sides. 80 equals 2x, so therefore x equals 40. And since x equals 40, we automatically know that a equals 40. So I'll just write it like that. X and a equal 40. Got two more angles to find, K and B. Well, what do we already know about K and B? Well, the diagonal bisects, so therefore K equals B. Now we just got to figure out the number. So let's see what we know. I'm going to write in measures here. Well, if we know that's 90, that means this must be 90. A is 40. X is 40. Well, you could probably figure out different ways to solve for this. You know that this angle combined, 80, is supplementary to this angle. Or you could use the triangle sum theorem. We could say, okay, there's 180 degrees in this triangle. So we could say 180 equals 40. Plus we know that's 90 because diagonals are perpendicular, plus angle K. And then you could solve. 130 is 180 plus angle K minus 130, so therefore K equals 50, B equals 50. And that's how you would solve for rhombus geometry problem. And that is the end of lesson 39.